from unaligned UAV imagery to interpretable PDE solvers and real capital AI traders. Today's papers show how the field is moving beyond raw prediction towards structured intelligence. We'll look at a segmentation system that calibrates both geometry and semantics, a hybrid operator that learns reusable physics primitives, and an on-chain agent stack where reliability depends on the whole operating layer, not just the model. Together, they reveal a common theme. Smarter AI comes from better composition, control, and context. Let's explore the first paper. Graph-based semantic calibration network for unaligned UAV, RGBT image, semantic segmentation, and a large-scale benchmark. This paper tackles unaligned UAV RGB thermal semantic segmentation with GSCNet, a two-stage calibration framework built on dual MIT, B4 encoders, and a segformer decoder. Its first novelty, the feature decoupling and alignment module, separates each modality into shared, structural, and private perceptual subspaces using asymmetric encoders, then estimates bidirectional deformable offsets only in the shared space with DCNV2 and an illumination-aware router that switches the alignment anchor between RGB and thermal cues. Its second novelty, the semantic graph calibration module, converts the fuse prediction into a 6-1 node category graph whose adjacency combines a 3-level taxonomy prior, a data-driven co-occurrence prior, and a learnable residual, then refines class embeddings with a prior-biased 4-head graph attention network. To support this problem setting, the authors release URTF, the largest fine-grained, unaligned UAV RGBT benchmark, with 25,519 real and synthetic image pairs, 61 classes, and realistic cross-modal misalignment at 640 x 512 resolution. On URTF, GSCNet reaches 71.04% MIOU and 60.17% IOU on the 16 rarest classes, outperforming MambaSeg by 2.73 points and AMDA Net by 2.91 points in MIOU, while improving over the strongest RGB-only segformer baseline by 10.99 points. Ablations show that FDAM contributes plus 2.5 MIOU, SGCM adds plus 2.67, and together, they raise performance by 3.41 points, confirming that geometric correction and semantic calibration address complementary failure modes. Let's explore the second paper, HiCop Hybrid Composition Operators for Interpretable Learning of PDEs. HiCop introduces a query-conditioned composition framework for learning PDE solution operators by selecting, rather than blending, reusable primitives such as advection, diffusion, reaction, boundary handling, and learned residual closures. A small policy network with roughly 5,100 parameters maps the input state, parameters, and query time to a short program of primitive duration pairs, enabling direct multi-time inference without autoregressive rollout. The key novelty is that the learned object is the composition schedule itself, not a monolithic operator. On 2 decompressible Navier-Stokes, HiCop achieves NRMSE 4.04 x 10, -2, beating Strang splitting by 47% and FNO by 89%, while preserving conservation error at 1.59 x 10, -8. On 2D shallow water equations, it reduces OOD relative L2 error from 3.5 for 3.8 x 10, -1 for leading neural baselines to 5 x 10, -2, a roughly 7 times improvement. On 2D ADR, it reaches 2.87 x 10, -2 OOD, about 8 times better than lock. Int, diff, FNO. The framework also supports modular transfer, swapping a periodic boundary primitive for a wall boundary module on dam break, sweet cuts error from 3.82 x 10, -2 to 9.92 x 10, -3 without retraining, and enriching an AD dictionary with a learned UNO residual lowers ADR error from 1.81 x 10, -1 to 4.42 x 10, -2. Theory establishes density of finite composite flows, a decomposition into splitting error plus primitive error, and universality within this structured hypothesis class, making failure localizable to a specific process rather than the entire surrogate. Let's explore the third paper, Operating Layer Controls for On-Chain Language Model Agents under Real Capital. This paper studies autonomous language model agents that trade real ETH under irreversible on-chain settlement, using DX Terminal Pro, 3,505 user-funded vaults, 7 5M agent invocations, about true sense on-chain actions, 5,000 plus ETH deployed, and roughly $20M in volume over 21 days. The key finding is that reliability is an operating layer property, not a model-only property. The full path from on-chain user mandate to compiled prompt, typed controls, policy validation, execution guards, memory, and settlement determines whether an action is valid. The authors used Quinn 3235B, A22B, thinking 2507 via SG Lang, and froze the runtime stack to isolate harness effects. Pre-launch replay tests exposed 5 failure modes that text benchmarks miss, including fabricated rules, fee paralysis, numeric hardening, tokenomics misreads, and cadence trading. Small harness edits produce large shifts. Fabricated cell rules dropped from 57% to 3%. Fee-led observations fell from 32.5% to below 10%. And capital deployment in one affected cohort rose from 42.9% to 78%. In a separate internal EVM swap task, aligned successful transaction construction improved from 87% with Claude 4 to 96% with Claude 4.6, and the DX Terminal Pro style harness lifted that to 99.9%. Production traces also showed ordered gradients for all 5 user sliders, strong herding cascades, such as 1,544 vaults buying feet within 1 hour, and 3,878 cell cascades, while structured controls and explicit exit conditions correlated with materially better outcomes than vague outperform instructions. That's a wrap on today's AI paper highlights. Thanks for watching.